Hello everybody. Okay, let's continue here the covalent bonding, and today we will discuss the simple covalent molecules. Okay, so we said before that covalent bonding happens only between nonmetals, though many nonmetal elements such as hydrogen exist in simple diatomic molecules, and this is what I explained last time. Why the nonmetals, or let's say all gases except the inert gases, are in diatomic molecule H2O2 N2, because we said that they don't have the perfect structure. They want to reach this perfect structure by the help of another nonmetal element, maybe from the same type or from some other type. Okay. So for hydrogen, as you see, two hydrogen atoms, and I explained that last time, this one needs an electron and this one needs an electron. So you share with what you need. Like I need an electron, so I share an electron. I need two electrons, I share two electrons. So what happens here, hydrogen needs one electron, the other hydrogen needs another electron. Each one of them will share with an electron. This is what happens at the end. So H becomes H2. This is how we find hydrogen in the nature. So each hydrogen atom needs one more electron in its outer shell, and so that's how they share together, forming this type of bond. You have to understand something. If each atom shares with an electron, we call the new bond single covalent bond. It is single covalent bond, only one pair of electrons. This is what we call single bond. Let's see here, how do the elements such as chlorine again forming a bond. Let's see. Now, since you know that the structure of a chlorine is 287, so the perfect structure is to have 8 electrons in the outer shell. So this means chlorine needs one electron. Okay, so this means also that chlorine will share with one electron. Very good. So what happens here, a chlorine and a chlorine go and bond together in what we call single bond. Single bond, okay. Now oxygen. Oxygen is 2,6. So the last energy level, or the last shell, needs 2 electrons. So in that case, oxygen will share 2, because oxygen needs 2. Again. Okay. This is chlorine. Let's see oxygen now. This one will share with this one with 2 electrons. How can you make sure that it reaches the perfect structure? When you cover this here, you have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 electrons. And if you cover this, you have 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8. Each one of them seems to be having 8 electrons in the last shell. So that's how they feel more perfect. Okay, oxygen. Let's see another example. So this is here, the oxygen, each one shared with 2 electrons. So I have here in the middle 1, 2, 3, 4, which is 2 pairs of electrons, and this is what we call double bond. We call this double bond because each atom shared 2 electrons. If an atom shares one electron, this is single bond. The atom shares 2 electrons, double bond. So let's see an example of the triple bond. This is how we draw it. Watch this. Nitrogen and nitrogen. The electron configuration is 2, 5. So the last shell has 5. We need to reach 8. This means nitrogen needs to get 3 electrons. Okay? So what happens? If you need 3, you share 3. And this is what happens exactly. If you see the one here to the left hand side, this atom shares 1, 2, 3. And this one with X's shares 1, 2, 3. So each one will share 3 electrons to form what we call a triple covalent bond or a triple bond. Okay, so now you have seen, and this is how we draw it. This is how we draw nitrogen. N 1, 2, 3 dashes N. This means triple bond, or oxygen 1, 2 double bond, or Cl, Cl single bond. Single, double, triple bond. Okay? Now, all the examples we mentioned, it was an atom of an element and the same type of this element, like hydrogen with hydrogen, oxygen with oxygen, nitrogen with nitrogen. But today, we'll give another example of hydrogen and chlorine, 2 different atoms. Non-metal, non-metal, because remember that covalent bond is formed only between non-metals. Okay, hydrogen from the periodic table is H1, so it has only 1 electron, as you see here. Chlorine is Cl17, its electronic configuration 287. It has 7 in the last shell. We draw only the last shell here. 1, 2, 3, 4, 5, 6, 7. Okay? Now, the question is, the hydrogen wants to reach the inert gas, which is helium, He2. So it needs 1 electron. It needs 1 electron to look like helium. Here, 287, and the nearest one here is argon. They are another inert gas, 18. The structure is 288. Last shell has 8, perfect structure. Chlorine wants to be the same, has only 7, needs 1. Okay, very good. So if hydrogen and chlorine together, now they think, I need an electron, you need an electron. Chlorine needs 1, hydrogen needs 1. Let's share. Hydrogen will share 1 electron since it needs 1. Chlorine shares also an electron since it needs 1. So what happens? What happens? They bond together, 2 nonmetals. 1, this shares 1, this shares 1. Now, if you count the electrons around hydrogen, in the last shell it's 2. And here in chlorine it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect, very good. Oxygen with hydrogen. Okay, what happens? Again, hydrogen is 1. Needs 1. The same with this hydrogen. Needs 1. Here, oxygen is 08. Electronic configuration is 26. Okay? So the last shell has 6. What does the oxygen need to reach the perfect structure? Needs 2 electrons. Perfect. Hydrogen needs 1. The other hydrogen needs 1 also. Now, let's share together. Let's share together. So, hydrogen will share its electron, and the other hydrogen will share its electron, since the oxygen has 1, 2, 3, 4, 5, 6. Now, they combine together in a covalent bond. As you see, it is going to be O, single bond with H, from the other side, another single bond from H, and this is H2O molecule. Share, 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 and so on. This is how we bond by using covalent bond. This type of bond is single covalent. Okay, to calculate the ratio of atoms in a stable covalent compound, work out how many electrons are needed by each nonmetal element to complete its outer electron shell. Then work out the ratio. Let's see an example. Now, I have nitrogen and hydrogen. I want to know the electron configuration. Okay, nitrogen is N7. N7. N7 means the electron configuration is 2,5. Hydrogen is 1, so electron configuration is 1. Okay, very good. Now, next thing. How many electrons needed? For nitrogen, it is 5. The nearest perfect structure is to have 8. So, what happens that nitrogen needs 3. Hydrogen needs 1 to reach helium, and this one to reach neon gas, Ne10, inert gas. Okay, so now the ratio of atoms is okay. What this reminds you? It is the crisscross, guys. Crisscross. You remember the crisscross? N, H. In the third page in your formula sheet, you will find that N has 3, hydrogen 1. And when we want to combine these elements together, we do this. Cross. And the final result is N1H3. This is how it works. Okay, you got this? This is what happens. Nitrogen needs 3 electrons, so it shares 3 electrons. Hydrogen needs 1 electron, so it shares 1 electron. Now, so the 3 hydrogen atoms, each one will share. Let's see this hydrogen. How many electrons around this hydrogen? 2. How many around this? 2. How many here? 2. Now count the nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Okay, very good. Now let's take another example. It is methane, CH4. If you open your formula sheet, the first page, the periodic table, you will find C has 4. You remember that? 4. And H valence number is 1. Crisscross, it must be C1, H4, CH4. Okay, so how does it work with electron configuration? Carbon, electron configuration 6 means 2, 4. Hydrogen 1. Electrons needed here 4, here 1. The ratio, you crisscross. So this is what happens in real life. 1 carbon, 4 hydrogen atoms forming this compound. This is how we represent it. This is the formula, CH4. And here it is how it looks like we're bonding, and this is how we represent the covalent bond for this molecule. Another example, carbon dioxide. Carbon is C6. Oxygen is 8. Electronic configuration 2, 4. For oxygen 2, 6. Now ask yourself, how many electrons carbon need? Okay, very good. Now you want to reach 8, you need 4. Here, how many electrons you need? 2, and so on. Very simple. So the ratio, okay, CO, this is 4, this is 2. Remember, simplify. So it is CO2. Perfect. 4, 2, simplify, cross, carbon, O2. The carbon here shares with 4 electrons, 2 for this oxygen and 2 for the other one. If you share with 2, it means double covalent bond. If you share 1, this is single covalent bond. As you see, the carbon shared with 2 electrons to this side, so it is double covalent. And 2 from the other side, so it's also double covalent. So C, double covalent bond, O, double covalent O. Okay, I will stop here. Thank you. Take care. Stay safe.